So right now, as you're listening to my voice, there is this microscopic high-performance engine running deep inside your skull.
And it literally never sleeps.
Right, exactly. It never gets to turn off. And just like a car engine, because it's running so hard all the time, it's constantly producing this toxic cellular exhaust.
Which is a huge problem if you don't clean it up.
Exactly. If you don't actively clear that exhaust, the engine starts to break down. So today, we're doing a deep dive into a source called the ECHOXEN conversation, nutritional pathways to auditory wellness. And the mission today is to figure out how the food on your dinner plate is like practically the only thing keeping that microscopic engine running.
It really completely reframes how we think about our bodies. I mean, we usually view our ears as these passive, mechanical funnels, you know?
Yeah, totally. Like, just avoid loud concerts, wear your earplugs, and you'll be fine.
Right. But this source looks at hearing as a highly aggressive, metabolically demanding biological process. It requires constant fuel.
And that is exactly what we are going to dig into today for you. Because if you want to understand how your body actually works, you have to look past the physical structures and, look at the microscopic chemistry.
You really do.
Okay, let's unpack this because before we get into the vitamins, we need to know what we're feeding. I think a lot of people just picture the ear as a biological microphone. Sound goes in, hits a drum, and we hear it.
It's a common misconception, yeah.
But you're saying it's way more active than that. So what is actually happening inside the ear when a sound wave hits it?
Well, think of it less like a microphone and more like a highly coordinated, high-stakes relay race.
Hmm.
And the baton actually changes physical form mid-sprint.
Oh, wow. Okay, mid-sprint.
Yeah, so it starts mechanically. The outer ear catches the sound wave, funnels it down, and it hits the eardrum.
Right, the mechanical part.
Exactly. That vibrates 3 tiny bones in your middle ear, which then push against this fluid-filled, snail-shaped organ called the cochlea.
Okay, so far, it still sounds like a drum moving water. Where does the relay race come in? Like, how does moving fluid turn into something the brain can actually understand as language or music?
So inside that fluid-filled cochlea are thousands of incredibly specialized sensory cells. They're called hair cells.
Because they look like hairs.
Exactly. They have these microscopic hair-like projections called stereocilia. And when the fluid in the ear creates a wave, it physically bends those stereocilia.
Okay.
And this is the crucial handoff in the relay. That physical bending literally pulls open tiny trapdoors on the surface of the cell, which are called ion channels.
It literally pulls them open.
Literally pulls them open, and when those doors open, chemicals rush in, and the cell fires off an electrical spark. It's just converted a mechanical water wave into a digital electrical signal.
That is wild. The physical bending of the hair pulls open a microscopic trapdoor.
And then that signal travels up the auditory nerve to the brain.
But wait, if I'm, listening to music or just walking down a noisy street, there's constant sound. Are those little doors just violently opening and closing thousands of times a second?
Thousands of times a second, yes, exactly. And that brings us right back to your engine analogy from earlier.
Because of the energy it takes.
Yes, the sheer amount of cellular energy required to constantly open those channels, pump the chemicals back out, and reset the cell for the next sound wave is staggering.
I can't even imagine.
These sensory cells have one of the highest metabolic rates in the human body. Even when you're asleep in a quiet room, they are actively maintaining a resting electrical charge. They're just standing at the smoke arena ready for a smoke alarm or a breaking window.
Wow, so they never really get to turn off.
What's fascinating here is that because they never turn off, they are constantly burning energy.
And so if these cells are constantly firing and burning energy, what happens to the waste? You mentioned a high metabolic rate produces exhaust. What is that exhaust doing to the ear?
Well, the scientific term for that exhaust is reactive oxygen species, but they're commonly known as free radicals. When any cell burns energy, it creates these unstable molecules as a byproduct.
Right, I've heard of free radicals in skincare and stuff.
Yeah, it's the same concept. You can picture a free radical as an atom that is missing an electron. Because it's chemically unstable, it violently tears through the surrounding cellular environment. It rips electrons away from healthy tissue just to stabilize itself.
Oh, geez. So it's basically stealing from the ear cells.
Exactly. And this causes a chain reaction of damage known as oxidative stress.
Wait, so the cells in the inner ear are essentially polluting their own microscopic environment just by doing their normal job?
Precisely. And if the body doesn't clear those free radicals, they will literally chew through the structural proteins of the hair cells. They'll damage the cell membranes and eventually cause the cell to die.
And let me guess, we can't just grow new ones.
No, we can't. Unlike bird or reptile hair cells, human inner ear hair cells do not regenerate. Once they are gone, they're gone forever.
Wow. Which, I mean, that completely explains why the source material spends so much time talking about specific nutrients, right? Like amino acids.
Right, exactly.
Because if the hair cells are constantly under attack from their own exhaust, I assume they need a massive amount of raw material to rebuild their walls and keep those trapdoors functioning.
Yes, and that is where the dietary amino acids come into play. Amino acids are the literal building blocks of proteins.
Okay.
So your body uses them to synthesize the structural components of the inner ear that are constantly wearing out. But beyond just structure, certain amino acids are critical for synthesizing neurotransmitters.
Oh, right, because it's an electrical signal.
Exactly. Remember, that electrical spark has to jump across a gap from the hair cell to the auditory nerve. It uses chemical messengers neurotransmitters to make that jump.
So without those, the signal just fails.
Without a steady supply of dietary amino acids, that chemical communication breaks down and the signal gets muddy.
Okay, so the body needs amino acids to basically rebuild the track for the relay race. But what about stopping the damage in the first place? If oxidative stress is the exhaust tearing up the cells, what exactly is the body using to clean it up? Because the source lists a whole alphabet soup of vitamins.
Yes, it does.
Vitamin C, E, magnesium, B vitamins. But honestly, it reads a bit like the back of a cereal box. How does swallowing a magnesium capsule actually help a microscopic trapdoor inside my cochlea?
Well, let's look at the exact mechanism, starting with magnesium, because its role is fascinating. Every time that hair cell we discussed fires off an electrical signal, it relies on calcium to trigger the spark.
Okay, calcium rushes in.
Calcium rushes into the cell and boom, the signal is sent. But in noisy environments or if the ear is under stress, the cell can actually become overstimulated.
Meaning too much calcium.
Yes, too much calcium rushes in at once, and if that happens, the cell essentially vibrates itself to death. It becomes toxic.
Oh, wow. So what does magnesium do?
Magnesium acts as a physical gatekeeper. It literally blocks the calcium channels, regulating the flow so the cell doesn't become toxic and destroy itself.
Wait, really? So magnesium isn't just some generic health mineral?
Yeah.
In the ear, it's acting as a literal physical shield against sound overstimulation.
Exactly. It prevents the engine from redlining.
That is incredible.
Now let's look at the B vitamins, specifically B12 and folate. Because once the hair cell survives the sound wave and fires the electrical signal, that signal has to travel down the auditory nerve to the brain.
Right, the next leg of the relay.
Right, and the auditory nerve is basically a biological wire. But just like an electrical wire in your house, if it isn't insulated, the current leaks out, slows down, or short circuits.
Here's where it gets really interesting. This is the myelin sheath, right?
Yes, exactly. The myelin sheath is a fatty protective layer wrapped around the nerve. B vitamins are biologically required to synthesize and maintain that myelin.
So if you're deficient in B vitamins, what happens?
The insulation basically frays. The signal leaves the ear perfectly fine, but by the time it reaches the brain, it is distorted and weak.
Okay, so the magnesium keeps the cell from exploding, and the B vitamins act like the protective insulation and the conductive copper, keeping that wiring fast and clear.
That's a great way to put it, yeah.
But what about vitamin C and E? Are they the ones actually fighting the free radicals we talked about earlier? The exhaust?
Yes, they are. Vitamins C and E, along with the mineral selenium, are the chemical neutralizers.
How do they work?
Well, when those unstable free radicals are tearing through the inner ear looking for an electron to steal, an antioxidant like vitamin C steps in and basically says, here, take mine.
Oh, so it sacrifices itself.
It voluntarily donates an electron, neutralizing the threat before it can damage the cell membrane.
And what about selenium? You mentioned that too.
Selenium acts a little differently. It activates a powerful enzyme in your body called glutathione peroxidase.
That sounds intense.
It is. It's basically the heavy artillery your body uses to dismantle oxidative stress.
Wait, I need to stop you there.
Yeah.
Because I understand the chemistry of this now.
Yeah.
It makes perfect sense on a microscopic level.
Right.
But practically speaking, how does this actually work? The ear is a sealed bone vault deep inside the skull. If I eat a spinach salad or, take a selenium supplement, it goes into my stomach.
Yes.
How does digesting a vitamin in my digestive tract actually make its way up into my skull to change how I hear?
This is a great question, and it's where the biological vulnerability of the ear really becomes apparent. The answer is your cardiovascular system, specifically a single tiny vessel called the labyrinthine artery.
The labyrinthine artery.
Right. See, the inner ear does not have a massive network of blood vessels feeding it. It is entirely dependent on this one, extremely fine artery, to deliver all the oxygen, amino acids, magnesium, and vitamins we just discussed.
Oh, wow. Just one.
Just one. It is an end artery, meaning there is no backup collateral blood supply.
So if it gets blocked.
If that one tiny pipe gets clogged, or if your microcirculation is sluggish, the inner ear structures are instantly starved.
So what does this all mean? It means your ears don't exist in a vacuum. Cardiovascular health isn't just about preventing a heart attack. If my blood flow is weak, those high-performance hair cells don't get their antioxidants, they choke on their own exhaust, and they die.
Precisely. You could have the most nutrient-dense diet in the world, but if your microcirculation is compromised by poor cardiovascular health, none of those nutrients will ever reach the cochlea.
So the delivery system is literally just as important as the fuel itself.
It really is.
That makes the whole system seem so incredibly fragile. And, I mean, it also explains why the source material brings up mental clarity and cognitive support so much.
Oh, absolutely.
Because if the blood manages to pump the nutrients through that tiny artery, and the hair cells fire the signal, and the insulated nerve carries it up, well, the final runner in this relay race is the brain.
Which is a distinction people rarely make. There's a profound difference between hearing and listening.
Oh, interesting. Say more about that.
Hearing is the mechanical and electrical transduction in the ear. It's the physical process. Listening, decoding language, focusing on a specific voice, filtering out background noise, that all happens in the auditory cortex of the brain.
So I'm at a crowded restaurant, and I am struggling to understand the person sitting across from me amidst the clattering plates and other conversations. Is that an ear problem or a brain problem?
It is very often a cognitive processing problem, specifically related to something called the signal-to-noise ratio.
Signal-to-noise ratio.
Yeah. So in a loud environment, your ear is sending thousands of signals to your brain simultaneously. The brain has to rapidly sort through that chaotic data, suppress the useless noise of the clattering plates, and amplify the specific frequency of your friend's voice.
That sounds exhausting.
It requires immense cognitive energy.
So if my brain is fatigued or starving for nutrients, it essentially experiences a lag. The ear is working perfectly, but the processor is crashing because there are too many browser tabs open.
That's a perfect analogy. Exactly. The auditory cortex simply can't process the data fast enough. And if we connect this to the bigger picture, this interconnectedness is why you cannot isolate auditory wellness from cognitive and cardiovascular wellness.
Because they're all feeding into the same system.
They are entirely dependent on each other. If your brain is exhausted, your hearing suffers.
Okay, we have covered the biology, the chemistry, the delivery system, and the processor. Now, let's talk about how you, the listener, actually apply this.
Right, the practical side.
Do we need to go build a lab in our basement to extract exact milligrams of selenium, or is this something we can manage at the grocery store?
The foundation of this is always going to be the grocery store. You want whole foods that target these specific biological mechanisms.
Okay, so what should we be buying?
Well, for the amino acids to rebuild the cellular structures, you are looking at high-quality proteins, things like fish, poultry, eggs, and legumes.
And for the magnesium to protect the ear from overstimulation.
To get that magnesium to protect your calcium channels, you want spinach, pumpkin seeds, and almonds.
Okay, got it. And for the antioxidants and B vitamins, the cleanup crew and the insulation.
Leafy greens and citrus are excellent for vitamin C, nuts and seeds for vitamin E, and for the B vitamins to maintain your nerve insulation, you really want whole grains, eggs, and dairy.
So a pretty balanced diet, basically.
Yeah, the rule of thumb is color and variety. That ensures you're getting a broad spectrum of the cofactors your body needs to actually absorb these nutrients.
Now, the source material frames this whole nutritional approach around a specific formulation they call ECHOXEN.
Yes, they do.
And treating this purely as a piece of data to be analyzed, what are they actually trying to do with this supplement? If I can get spinach and eggs from the store, what is the biological argument for a product like this?
Looking at their formulation objectively, they are essentially trying to bottle this exact biological theory we've been discussing.
Like an all-in-one package.
Right. They've taken the amino acids for structural repair, combined them with the specific antioxidants like vitamin C and selenium for the free radical cleanup, and added the B vitamins for the nerve insulation.
And it's a liquid format, right? Does that actually matter, or is that just, marketing?
Biologically, the format does matter for bioavailability.
Okay.
A liquid suspension often bypasses the need for the stomach to break down binders and fillers found in hard capsules.
Which means what exactly?
It means the active nutrients can enter the bloodstream and eventually that labyrinthine artery much more efficiently. The argument they are making is that calculating and maintaining this exact micronutrient balance across dozens of whole foods every single day is, well, practically impossible for the average busy person.
You're busy, so how do you fit this in? It sounds like it's designed to be a bridge. You still have to eat the spinach, but this ensures you don't miss a day of feeding the engine.
Correct. The educators in the source material are very clear that it is an addition to, not a replacement for. You cannot out-supplement a terrible diet or a horrible lifestyle.
Right, which brings up the holistic side of this.
Yeah.
Nutrition is just the chemical fuel. You still have to manage the physical environment.
Exactly.
Because if I eat perfectly but go to a rock concert every night without earplugs, my hair cells are still going to vibrate themselves to death.
Exactly. Physical protection from intense noise trauma is absolutely non-negotiable. But beyond that, we really have to look at sleep and exercise.
Sleep helps the ear.
Yes. Sleep is when the brain physically clears out metabolic waste and the inner ear undergoes its deepest repair cycles. If you don't sleep, the oxidative stress compounds.
And exercise.
Exercise is the only way to ensure your heart is pumping blood forcefully enough to actually reach those tiny microvessels in the cochlea.
Wow. It is incredibly empowering to realize how much control we actually have over this. I mean, we tend to view hearing loss as this inevitable passive decline. Just a tragic part of getting older.
Many people do, yeah.
But understanding the mechanics, knowing that hearing is an active, metabolically demanding system that relies on physical fuel, it changes everything. By providing your body with amino acids to rebuild, antioxidants to clean up the toxic exhaust, and vitamins and minerals to insulate the wiring and protect the cells, you're actively keeping that system alive.
It is a total paradigm shift. And when you look at all of this interconnected data, it points to a fascinating, if slightly unsettling, conclusion.
Really? What's that?
This raises an important question. If the structures of the inner ear are completely reliant on this one microscopic artery, and the auditory cortex requires so much cognitive energy to process sound,
Right.
then hearing loss might not actually start in the ear at all.
Wait, really? Where would it start?
Well, since the auditory system is so fragile and demanding, a subtle change in your ability to follow a conversation in a noisy room might actually be one of the earliest, unignorable warning signs of systemic cardiovascular or cognitive decline.
Oh my God.
The ear is essentially the canary in the coal mine for the heart and the brain.
Wow. If your blood flow drops, the ear starves first. That is going to stick with me. It forces you to look at your entire body as one unified system. Thank you for walking through the mechanics of this with me.
My pleasure.
And for you listening, we hope this deep dive has completely changed how you view your hearing, your health, and the food on your plate. Keep learning, stay curious, and maybe enjoy a handful of antioxidant-rich berries today. Your ears, your heart, and your brain will definitely thank you.